You have seen that when a plane intersects the nap of a cone at any place other than the vertex, such that the angle between the plane and the axis of the cone is 90 degrees. The section of the cone is a circle. Let us recall the definition of a circle. A circle is the set of all the points in a plane that are equidistant from a fixed point. The fixed point is called the center of the circle. The distance between any point on the circle and the center is called the radius of the circle. A circle can have an infinite number of radii, and all its radii are equal. Now, let us derive the equation representing a circle on a coordinate plane. Let point P with the coordinates h and k be the center of a circle. Consider a point M on the circle. Now, by definition, distance PM is equal to the radius of the circle. Recall the distance formula used to find the distance between 2 points whose coordinates are known. Applying the distance formula, we find an expression for the radius of the circle in terms of the coordinates of its center, P, and a point M on it. Squaring both sides, we get the equation representing a circle in a coordinate plane. In this expression, h and k represent the coordinates of the center of the circle and r represents its radius. Now, let us consider a circle whose center lies at the origin. In this case, both the coordinates of the center of the circle will be 0. Putting the values of h and k as 0 in the equation of the circle, we get the equation representing a circle with its center at origin and radius r. This is the simplest form of the equation of a circle. Let us find the equation of the circle with the center at the point 3, 2 and radius 3 units. Here, the x-coordinate of the center, or h, is equal to 3. The y-coordinate of center, or k, is equal to 2, and the radius r is equal to 3. Putting in the values of h, k, and r, we find the equation of the given circle. Let us simplify the equation further. Let us open the brackets and rearrange the terms. Thus, we get the final equation of the given circle as x square plus y square minus 6x minus 4y plus 4 is equal to 0. Both the equations shown here represent the same circle. Now, let us further rearrange the terms in equation 2. This gives another form of the equation of a circle, called the general equation of the circle. Note that minus g and minus f represent the coordinates of the center of the circle, and c represents the constant term in the equation. Thus, in the general equation of a circle, the coordinates of the center are given by minus g and minus f. In the general equation of a circle, the radius is given by the square root of g square plus f square minus c. Note that every equation of the form x square plus y square plus 2gx plus 2fy plus c is equal to 0 represents a circle only if the value of g square plus f square minus c is greater than or equal to 0. If the value of g square plus f square minus c is 0, then the equation of this form represents a point circle, which is nothing more than just a point or the center of a circle. If the value of g square plus f square minus c is less than 0, then the equation of this form represents an imaginary circle with a real center.